12.7, Graphing Using Vertex Form. This is our day 1. The first thing we're going to do with graphing vertex form is we're going to talk about transformations. Now, transformations from the parent graph, y equals x squared. Once again, this is our parent graph because nothing has been transformed from it or moved at all. Now, these transformations should look pretty familiar. The rules have applied for the same type of problems when we graphed absolute value graphs, when we graphed exponential functions. We still had transformations for all these types. These transformations are no different. Our a term on the outside of this, our a term, if a is less than 0, in other words, if a is negative, we have a reflection over the x-axis. If our value of a, doesn't matter if it's positive or negative, that's why we have the absolute value. If the value of a is greater than 1, we have a vertical stretch. And if the value of a, whether it's positive or negative, is between 0 and 1, any kind of fractions like 1/2, 3/4, we have a vertical shrink. Okay, so hopefully those sound pretty familiar. And then we had our h value. In this case, we have it as x minus h quantity squared. Our h value, if you remember, is like our hips. Our hips move us from left to right. So our hips is our horizontal translation. If the hips, the h part there, if it is a positive h, that means our graph is moving to the left. It was the opposite of what we expected to happen. When we move our hips to the right, our body moved to the left. If we have a negative h, that means our graph is translating to the right. If we move our hips to the left, our body moves to the right. It's the opposite of what we expected. Our k is like our knees. Our knees moved us up and down when we moved. So this is our vertical translation. If we have a positive k, it moves just like our body moved. Our knees moved up, our body went up. So our graph will shift up. If we have a negative k, it does exactly what we expected to happen. If our knees move down, our body moved down. Aren't you glad I'm not here to make you stand up and go left and right and up and down? But it is a good way to remember these things for which way this thing will transform. So let's go ahead and talk about these transformations from the parent graph y equals x squared. Our first one we can notice are 2x squared plus 5. Our a value of this problem is equal to 2. So that means we have a vertical stretch by a factor of 2. Okay? And then if we look at our original problem here, this had a parentheses with x minus h quantity squared. This one does not have a parentheses with x minus or plus a number, so we do not have a horizontal translation on this one. But on the outside parts, this is our k. The plus 5 on the outside is our vertical translation. So if it's a plus k, our graph is going to go up. So that plus 5 is a vertical translation up 5 units. Okay? And that's all of the translations or transformations for this problem. Our next one, h of x equals 2/3 x minus 4 quantity squared. So the first thing I notice is my a value again, 2/3. So that means if I go up to my chart up for my a value, it's positive, so it's no reflection. A value is not greater than 1, it's actually less than 1. So between 0 and 1 is our vertical shrink. So we have a vertical shrink by a factor of 2/3. And then I look at this part right here, and this is the part that's inside parentheses this time. So inside the parentheses is our horizontal translation. Now we have to determine our horizontal translation. If it is -4, that means our graph is moving to the right. The negative h means it goes to the right 4. So right 4 units. All right, if you want to pause the video and try out number 3 and push play when you're finished. Okay, so hopefully you try this one out if you want to try ahead of time. But we have here the negative sign this time on the outside. So the negative sign is my reflection over the x-axis. The next part I looked at is this 3. Now don't forget, the 3, the number, it doesn't matter what sign it is. If the value is greater than 1, it's a stretch. If the value is between 0 and 1, it's a shrink. So this value is 3 separate from the negative, so I have a vertical stretch by a factor of 3. The next part is the inside this parentheses. The inside is my horizontal translation. This time it was +1. So I had a horizontal translation left 1 unit. And the last part was the -3 on the outside. This is our vertical translation. So if it is negative, I have a vertical translation down 3 units. Don't forget when you do this on your homework, be as specific as you can and write the description for every transformation. Don't be lazy and write left 1. Please tell me the horizontal translation and the vertical translation. Be very specific. All right, so now what we're actually going to be doing with these problems is we're going to be graphing these in vertex form. So this, what we were just working with, our transformations, is called vertex form. Every parabola in this form has a vertex, and the vertex comes from your horizontal translation and your vertical translation. So we call our vertex h, k. Those numbers tell us what our vertex is. And they have a vertical odd pattern. So if we look at our parent graph, y equals x squared, I have graphed it for you. We can see that our vertex is 0, 0. And that makes sense now that we know our transformations, because if I look at this x squared, nothing's being added or subtracted on the inside, and nothing's being added or subtracted on the outside. So 0, 0 would be my h and my k. The next thing I want you to notice, we're going to make a table of this graph. Now, we know when we did standard form, we always put the vertex in the center, 0, 0, and then we're just going to list these points off. So left from that is -1, 1. We also have -2, 4, and we have -3, 9. On the other side of the graph, we have +1, 1, +2, 4, and +3, +9. Now, once again, just to notice it, don't forget we always have symmetry here on the left side to the right side. Now, I want you to kind of notice this odd pattern and where it comes from. If I'm looking at the y values, the distance between the vertex and the next point is 1. The distance between that point and the next point is 3. And the distance between 4 and 9 is 5. Now let's look at the other side. Since it's symmetrical, the distance between 0 and 1 is 1. The distance between 1 and 4 is 3. And the distance between 4 and 9 is 5. So this is how we find this odd pattern, because we have our odd numbers 1, 3, and 5 on both sides of the vertex. So this pattern works by going up 1 over 1, up 3 over 1, up 5 over 1, The reason we're only going over 1 each time is because that's just the x value, and we only go a distance of 1, distance of 1, distance of 1. So look at this pattern on your graph. Up 1, over 1. From the next point, I go up, so there's 1 and 1. I go up 3, over 1. And the next point goes up 5, over 1. On the other side, since we're symmetrical, it does the same thing. Up 1 over 1, up 3 over 1, up 5 over 1. So this distance, this odd pattern, will work for every quadratic. It may not be 1, 3, 5 each time, but it follows this 1, 3, 5 pattern. So let's talk about how this pattern is actually going to work. Well, in this chart, we have our multiple equations. We're going to first identify the vertex. Well, we know from our transformations that this plus 3 on the inside means we're going to go to the left 3. So our vertex is starting on -3. And then we know from this -4, we're going to go down 4. Now, if you didn't notice that from the transformations, basically what we're doing is we are taking the opposite sign from the inside the parentheses, because the hips do the opposite, and we're taking the same sign on the outside since they do the same for the up and down. Now, whether this one's going to have a min or a max, we know that our a term in this is equal to +1. So we know our graph has to open up. So it will have a minimum point, and that minimum point will be the lowest part on the graph. Well, the lowest part on the graph is also the y value of the vertex. So we can say the minimum equals -4. The axis of symmetry, don't forget, the axis of symmetry falls right in between the left and the right side of the graph. So the axis of symmetry, x equals, is also going to be the same value as the x value of the vertex. The last thing we're going to do with this is we're going to look at this odd pattern. The odd pattern works by multiplying the pattern by a. So in this case, my a value is equal to 1. So I'm going to multiply the odd pattern by 1. Well, 1 times 1 is 1, 3 times 1 is 3, and 5 times 1 is 5. So it's not going to change the 1, 3, 5. So just like last time, this one would go up 1 over 1, up 3 over 1, and up 5 over 1. Okay, let's look at the next one. Finding the vertex first. This -3 means we're going to go to the right 3, and then this means we're going to go up 5. So my vertex will be on the points +3, +5. And also, sign difference, the sign will be the same every time. This one has a value, a equals -1. So that means my graph is going to look something like this because of that negative number. This time my graph will have a maximum. The maximum value is the y value of the vertex, the highest points of the graph. The axis of symmetry falls the same as the vertex, so x equals 3. This time my a value is equal to -1, so that's the number I'm going to multiply my 1, 3, 5 pattern by. This time the number's not changing, but it's going to be the negative, -1, -3, and -5. So the only thing that's going to change is the direction. So I'm going to go down 1 over 1, and then I'm going to go down 3 over 1, and then I'm going to go down 5 over 1. This will make more sense when we're actually graphing our graph, but if we go down from those points, we're going to end up getting our graph opening down. Okay, the next one. If we look at this one, we have x plus 1 on the inside of parentheses, so that will give us the opposite sign of -1. and there's nothing added or subtracted, so the y value is 0. My a in this one is -2, so that means I'm going to have a reflection, and my graph will open down, meaning that once again I will have a maximum, and the maximum value is 0, the same y value of the vertex. My axis of symmetry will fall on the same line of the vertex, so x equals -1. My 1, 3, 5 pattern, since a is equal to -2 this time, I'm going to multiply by -2. So 1 times -2 gives me -2. So this time I'm going to go down 2 over 1. 3 times -2 is -6. So next I will go down 6 over 1. And the last one, 5 times -2 is -10, so I'm going to go down 10 over 1. Notice my over is always going to be over 1 because I'm still moving my x value just over 1 spot, but the y value changes depending on my a. And then our last one we have here, using the same knowledge that we had before, there's nothing being added or subtracted on the inside of the parentheses this time. So my x value is 0. And I have a -2 on the outside, so my y value is -2 for my vertex. My a value is equal to 1/2. Being positive, my graph will open up. And I have a minimum value, the same minimum value as my graph of my vertex will be on -2. My axis of symmetry will fall on the x value of my vertex, x equals 0. With my a value being positive 1/2, I'm going to multiply by a factor of 1/2 each time. 1 times 1/2 is 1/2. It is positive, so we're going to go up 1/2 over 1. 3 times 1/2 is 3/2. So I'm going to go up 3/2 over 1. And my 5 times 1/2 is 5/2, so up 5/2 over 1. And we can change these. 3/2 is the same as 1.5, 5/2 is the same as 2.5, and that will help us for graphing. All right, if this stuff seems a little bit intimidating, it is a little bit intimidating when you haven't graphed them yet. So let's go ahead and go to the graph. But that basic practice with knowing what our graph's going to look like is going to help us with the graphs. So flip your page over. And now we're going to practice using this vertex form. So our first problem is y equals 2 times the value of x minus 3 quantity squared minus 1. The first thing that I'm going to do is I'm going to find my vertex. My vertex is based on the horizontal and vertical translation. -3 tells me to go up, to the right 3, and -1 tells me to go down 1. So using the same opposite sign, my vertex will be +3, and then same sign, -1. My a value is equal to 2. So the next thing I'm going to do is set up my 1, 3, 5 pattern and see how I'm going to move the points after the vertex. So I'm going to multiply by my a. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. Okay, so here's how it all comes together and how it all works. I'm going to start by graphing my vertex. +3, -1. There's my first points on the graph, and if I reread my translations, I've got going to the right 3 and up, down 1. So from 0, 0, I go to the right 3 and down 1, and that's my vertex. The next thing I'm going to do is follow this pattern. Now these are all positive a values, so I am going to be going up and over 1. So the first from the vertex, I'm going to go up 2 over 1, and I'm going to plot that point. from that point, not from the vertex, from that point, my next one goes up 6, 1, 2, 3, 4, 5, 6 over 1. And if I had room, I would go up 10 over 1. Now we know that quadratics are symmetrical. So what I do to one side, I'm going to do to the other side. I'm going to go up 2 and over 1 on the other side. And up 6, 1, 2, 3, 4, 5, 6 over 1. And if I had room, up 10 over 1. And then I can draw a smooth parabolic curve. And I have successfully graphed y equals 2x minus 3 squared minus 1. The last thing we're going to do with this is domain and range. Domain for these values, all of my x values are in the reals because I can do all the way to the left and all to the right and pick up all of the x values of the graph. My range, however, all the y values, since it's opening up, are greater than or equal to the minimum value, which is -1. All right, let's practice another. The problem is y equals negative x plus 1 quantity squared. All right, the first thing I'm going to find is the vertex. My vertex for this problem, if this is plus 1, that means I'm going to the left 1. So my x value is -1. And there's nothing on the outside, so I'm not going up and down any. So I can graph this point, left 1 and up and down none. -1, 0. My a value on this problem is -1. So I'm going to multiply my 1, 3, 5 pattern by my -1. This will give us -1, -3, and -5. The reason these are negative is because for this graph, we're going to be going down. So from the vertex, my first pattern is down 1 over 1, down 3 over 1, and down 5. Almost fit on there, that's okay, over 1. And then I'm going to do the same on the other side. Down 1 over 1, down 3 over 1, down 5 over 1. And then I can connect my points in a smooth parabolic curve. And I have my graph. So my domain, x is in the reals for all real numbers. And my range, all of my y values this time are less than or equal to that maximum value of 0. Okay, hopefully that you're picking up on this pattern now. Pattern makes it a lot easier than having to make an XY chart. The next problem is y equals 2/3 x minus 2 quantity squared plus 1. Okay, so I'm going to find my vertex. My vertex in this case is +2, +1, since I would go to the right 2, and up 1. Now before we graph this, I'm going to do my domain and range, because you know all of the information you need to know for domain and range. Domain, always, x is in the reals, all real numbers. The range, all of my y values, well, this is a +2/3, so I know it's going to be greater than or equal to the lowest point on the graph. The y value or vertex will give you your lowest point on the graph, +1. We can graph it and check to see if we were correct. Okay, so I'm going to graph my +2, +1, and now I need to do my 1, 3, 5 pattern. In this case, A is 2/3. So 1, 3, 5, all times 2/3. 1 times 2/3 is 2/3. 3 times 2/3, well, 3 over 3 cancel and I get 2. And 5 times 2/3 is 10/3, or 3 1/3. So from the vertex, these are all positive, so I know I'm going up 2/3, which is not quite 1 over 1. The next one is 2, up 2 over 1. And the last one is up 3, 1, 2, 3, and 1/3 over 1, which will put us on that next perfect points. On the other side, up 2/3 over 1, up 2 over 1, up 1, 2, 3, and 1/3 over 1. Drawn a smooth parabolic curve. I know my domain is correct because all of the domains are all real numbers. My range, all of my y values are greater than or equal to +1. So I did it successfully. All right, moving on to our next example. Y equals -1/2 x squared plus 4. Okay, first finding our vertex. Our vertex in this case, we have nothing added or subtracted inside parentheses. So my vertex has an x value of 0. And then I have plus 4, which means I'm going up 4 units. So +4. I can do my domain and range early again. X's and elements of the reals. My y values, since this will be a negative graph, it's going to be less than or equal to the value, once again, of 4. Oops, couldn't even see that. Greater than or less than or equal to the y value of 4. All right, my 1, 3, 5 pattern is being multiplied by my a of -1/2. So 1, 3, 5, all multiplied to -1/2. That will give us -1/2, -3/2, or -1.5. And the last one is -5/2, or -2.5. So start by graphing your vertex, 0, +4. Our negatives mean that we're going to be going down. So from the vertex, I'm going to go down 1/2 over 1, down 1.5 over 1, and down 2.5 over 1. On the other side, down 1/2 over 1, down 1.5 over 1, down 2.5 over 1. And then draw on a smooth parabolic curve. Your quadratic. X is all in the reals, and the y values are less than or equal to my +4. All right, hopefully this is getting a little bit easier. Okay, our next problem is y equals x plus 2 squared minus 3. First I'm going to do is find the vertex. So for the vertex of this problem, this plus 2 means I'm going to go to the left 2. So I have -2, and this minus 3 on the outside would be down 3. The next thing I'm going to notice is this time my a value is equal to 1. So my 1, 3, 5 pattern won't change, because if I multiply each of these by 1, I'm going to get 1, 3, and 5. So if I graph my vertex, -2, -3, my 1, 3, 5 pattern is positive. So I'm going to go up 1 over 1, up 3 over 1, and up 5 over 1. Same with the other side. Up 1 over 1, up 3 over 1, and up 5 over 1. And then I'm going to connect my points. Domain for this one is all real numbers. And the range this time, all of my y values are greater than or equal to that bottom number of -3. All right, our last graphing problem, y equals negative 3x squared. So my vertex for this one, since I've got nothing added or subtracted on x and nothing added or subtracted on the outside, my vertex is 0, 0. My a term is equal to negative 3. So my 1, 3, 5 pattern multiplying to negative 3 will be negative 3, negative 9, and negative 15. The negative means I'm going to be going down. So starting my vertex on 0, 0, my first points will go down 3 over 1, down 9. Doesn't really fit, but we can kind of see where it would go. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. It's going to be a very skinny graph. Down 3 over 1, down 9 over 1. So we can graph this. My domain is all real numbers. X is an element of the reals. And my range, all of my y values, are all less than or equal to 0. Okay, so hopefully that these graphing ones went well. You can always review over them if you need some more help. Our last problem is going to help us with the next lesson. Analyze the quadratic function y equals x squared minus 6x plus 13 by completing the square. We're going to identify these key features after we complete the square. Well, let's write our problem down. Y equals x squared minus 6x plus 13. Now this one looks a little bit different than when we actually completed the square, but the steps in the process is exactly the same. I'm going to move my c term to the other side of the equation first. So I'm going to subtract 13, but this time it's not the only number over there. So I'm going to put y minus 13 equals x squared minus 6x. Now I'm going to complete my square to make a perfect square trinomial. I take my b term, which is 6, divide it by 2, and I square it. Well, 6 divided by 2 is 3. 3 squared is 9. So I'm adding 9 to complete my square. But just like we completed the square yesterday, if we add 9 to this side, we also have to add 9 to the other side to keep our equation equivalent. I'm going to rewrite this. Well, negative 13 plus 9 is negative 4. So y minus 4 equals, and I'm going to write my perfect square trinomial as the square of a binomial. Multiplying to 9 but adding to 6, this is my x minus 3 and x minus 3. So I rewrite this as x minus 3 squared. My last step, because we're not solving, we're just completing the square, is to get my y by itself. So I'm going to bring my 4 back to the other side of the equation. And I'm going to write my equation as y equals x minus 3 squared plus 4. Look, we have vertex form. We took a standard form equation, completed the square, and we got vertex form. Now we can identify all of the parts about this graph. So first, the direction of the opening. Well, if I look at here, my a term equals positive 1. So if a is greater than 0, that means my graph is going to open up. My vertex, well, I can pick out my vertex from this. Opposite sign, so this is going to be a positive 3, and same sign with the positive 4. Max or minimum value. Well, I know that this is going to be opening up, So it's going to have a minimum, and the minimum value is the y value of the vertex. And the number of x-intercepts. Well, I can kind of think about what this graph would look like. If my vertex was on positive 3, positive 4, 1, 2, 3, 1, 2, 3, 4, my vertex would be about here. I also know it opens up. So if it opens up, it would look something like this. Now we know that if it opens up above the x-axis, there's no x-intercepts. So my x-intercepts, we have none. It did not cross it once, it didn't cross it twice, it crossed it no times. Okay, if you have any questions on homework, first of all, do not forget that you can email me with questions. All right. Have a great afternoon.